Eric Furst will discuss a space station experiment and the science done on self-directed assembly.
The scientific and engineering objective that we have in this work, however, is to build things out of little building blocks, okay? And in particular, we want to build nanostructured materials, materials that have a structure, repeating structure perhaps, like these little dumbbell particles that have assembled into what you can see as a very ordered crystalline array. One of the key principles of this is we really want these things to build themselves. We want them to self-assemble. And the reason that you look for this type of behavior, this self-assembly behavior, is because you can take advantage of that to make low-cost, inexpensive nanotechnology. One of the things you have to be aware of is that actually this technology exists all around us, and we rarely see it in our day-to-day experiences because it's kind of invisible to us. It just functions. And a couple of examples are actually from other materials that we work on in my laboratory, many of the materials that surround us in our day-to-day life. Paints, foods, personal care products. Really the key of this is the idea that these particles, because they have Brownian motion, can reconfigure themselves, right? They can find different conformations among themselves. And that's what helps them build the structures. The chief scientific hurdle to doing this is the fact that if I take those bricks and I put them in a vessel and I concentrate them up and I expect a colloidal crystal to form, I get something which is known as a glass, something which is disordered and doesn't have that beautiful structure that you saw on the previous slide. And that takes us to the space station experiments. We've been studying on the space station how to circumvent these, what we call non-equilibrium states in these materials. What we've been able to show in those experiments and what we've been able to reproduce here on the ground based on those experiments is that we can build fantastic colloidal crystal structures from that. We can get self-assembly. And what we've discovered is a new pathway to self-assembly that we're trying to harness now to build other structured materials. All right?